Today I'm going to go over 12308, sprint 27. So the problem reads, Jenny writes down the positive integers from 1 to n inclusive around a circle and in order, where n is greater than 10. Her friend Julie then erases 10 consecutive numbers on the circle and observes that the sum of the numbers she erased is exactly 500. Let S be the smallest possible sum of the numbers remaining in the circle. What is the sum of the digits of S? So to begin, I've drawn out a diagram that represents the numbers around the circle. And so we can split the problem into two cases depending on whether the 10 consecutive numbers includes both 1 and n or not. So the first case is that they don't include 1 and n, and so the consecutive numbers would look something like this. And so that would imply that the numbers chosen by Julie is of the form a plus 1, and all the way up to a plus 9. So these are 10 consecutive positive integers, with the extra condition that a plus 9 is less than or equal to n. And so this sum is 10a plus 45, and we want this to be equal to 500. However, this is impossible because this yields a non-integer value of a, because 500 minus 45 is not divisible by 10. So we know that this case is impossible. And so it must follow then that the 10 consecutive numbers that Julie erases includes both 1 and n. So it looks something like this. And so we can parameterize these 10 consecutive numbers by considering 1, 2, all the way up to a, where 1 is less than or equal to a, which is less than 10. And also including n minus 1, all the way up to n minus 9 minus a. And we can verify that this is exactly 10 numbers because we have a numbers here, 1 number here, and 9 minus 8 here. And these three numbers sum up to exactly 10. So the sum of the first a numbers here is simply a times a plus 1 over 2, because that is the sum of the first a positive integers, whereas the remaining 10 minus a numbers forms an arithmetic progression. So we can simply add the first term with the last term and multiply by the number of terms all over 2. And we want this to equal exactly 500. So we can simplify this by expanding. So we have a squared plus a plus 2n times 10 minus a minus 90 plus 9a plus 10a minus a squared is equal to 1,000. And so the a squared here cancels out. And so we're left with 2n times 10 minus a plus 20a minus 90 is equal to 1,000. And so n times 10 minus a is 545 minus 10a, which implies that n is equal to 545 minus 10a all over 10 minus a, which is 10 plus 445 over 10 minus a. And so going back to the problem statement, we want to find the smallest possible sum of the numbers remaining in the circle, but the sum of the numbers remaining in the circle is simply the sum of all the numbers in the circle, which is n times n plus 1 over 2, minus the numbers erased, which is 500. And so note that maximizing n, so note that minimizing s implies minimizing n, but minimizing n because we have this expression here, implies maximizing 10 minus a. Now note that the prime factorization of 445 is 5 times 89. And we note that 1 is less than or equal to a, which is less than 10. And so to maximize 10 minus a, we know that 10 minus a must equal to 5, which corresponds to a value of n being 10 plus 445 over 10 minus 5, is equal to 99. So the corresponding value of s is 99 times 100 over 2 minus 500, which is 4,450. And the sum of the digits is 13, which is our final answer.
Hey, this is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.